Hello, Andrew here from GP3D. Welcome back. This is part 2 of our Blender beginner series for 3D printing. And in this part of the series, we're going to go and get stuck straight into designing our object. So we've got the part here, and it's a little rear shock tower from a vintage Pro 10 car from the Lucas agitator, and I'm going to show you how I go about doing a CAD design to replicate this part. Okay, so back to our object. So I've got a couple of holes here which are from the center, both 8 and 16 millimeters, and I'll go get some light to see what's that 2 mil hole, and maybe a 2.5. Yeah, interesting. So I've got a small hole and the big one, 2 and 2.5. Cool. So if I go to hit 7 on the numpad, go to the top view, I've already got a 2 mil hole, 2 mil diameter on this. So I want to move this object. So I'll use the green y-axis as my center line. So we're going to mirror, we're eventually going to mirror across the center line. I want to move this 8 millimeters out across along the x-axis. So I press G, which grabs it. So see now I'm just moving my mouse around. I've basically grabbed this object. Just moving the mouse moves it, but it moves it all sorts of places. It'll go crazy. So I want to move it in the x-axis. So I press X. So see how here it's locked to the x-axis. And I'm going to press the number 8. So 8 millimeters positive will move it in the positive direction on the x-axis by 8 millimeters. So that's where I want my hole to be from the center line. I haven't clicked enter yet, or the mouse button, so I've still basically got it grabbed, but I've told it x-axis 8 millimeters. If I press the minus key, I'm basically saying move it minus 8 millimeters from where it was, which is the center, well, its original position. I press minus again, it goes back to, cancels itself out basically, and goes back to a positive number, so positive 8. And then you can hit enter or left click, and that drops it. Now shift, move the mouse. I can sort of position this back into the center of the screen. Cool, so that's moved it. I'm going to measure my object, see how thick it is. So it's about 7.8 millimeters. So the eventual object thickness, 7.8. So I'm going to make this an arbitrary 10, because this is going to effectively make a hole. Cool. So now I'm going to go duplicate this object. You can create another one from scratch, or you could duplicate this. So I'm going to show you the duplicate feature. So if I do Shift D and let go, so it's duplicated. So see now my mouse has got hold of this duplicated copy. And again, I want to move it in the x-axis, so I press X. And I want to move it 8 millimeters as well, because this one's actually 16. I think this was 16 from centers, hopefully. Close enough. And a good thing with this method of designing is it's very, very easy to just move and change things at any point during your design process. Cool. And now I've got these two objects. So if I click on it, I can see the location of it. So it's 8 millimeters from origin of the x-axis. It's still on the y-axis because I haven't moved it from the y-axis. So it's 0, and I haven't moved it from the z-axis. So if we temporarily add the z-axis in, so we can see that's the vertical. And coming from the side, there's a few more shortcuts here I can show you, which are handy. So if I press 1. So number 1 on the numpad gives us the view from the y-axis effectively. So we can see like a side view from the y-axis. If I press 3 on the numpad, I get a view from the x-axis looking straight. So you can see here there, if I click and move them, they're behind each other. So this basically shows us the x-axis view. And 7. So 7 on the numpad gives us the top view from the looking down from the z-axis, and we can see our 2 cylinders there. The second hole looked like it was about 2.5 millimeters. So I'm going to change this to 2.5. So just click on the field you want to change, type in the new number, and then you can tab or click onto the different field and change that. So 7 on the numpad, top view. So now we can see I've got this 2.5 millimeter diameter hole. Now, from experience, I find that 0.2 is a good variation to make a hole if you want it to either be threaded into, so you want the screw to cut a good thread, you make it 0.2 millimeters smaller, and if you want the bolt or the screw to slide through, or pretty much slide through the hole, you add 0.2 millimeters. So if we've got an M2 hole, and which is 2 millimeters nominally, and I want to make the hole I think I've got a little tiny M2 bolt here. So if I want this, that goes straight in. So if I want that to be a slide fit, not a thread, I would make it 2 plus 0.2, so 2.2 millimeters. If I want it to be a threading hole, I would make it 1.8 millimeters. So instead of 2, I'll make it 1.8, and when I get an M2 screw, that screws right in. So that's what I found works for me, and it depends on all sorts of things, such as probably your software. It depends on the slicer, maybe. It depends on the material you're printing in, and it probably depends on the printer as well to some extent. So many variables. You'd probably need, it's a good starting point, I would suggest, and you would need to then work from there to see what works for you with all those different variables. So what have we got here? So this is actually, hole's actually 2.2, and this one's about 2.4 or so. And yeah, so I think a lot of this stuff is Imperial. So this has come off an Lucas Agitator Pro 10 car, which is American, which is from the 80s and would all have been designed using Imperial measurements and Imperial hardware. So what we've got here is probably 440 holes. So a 440 thread. So instead of an M3 being about 3 millimeters arbitrarily, I found that the 440 thread is maybe 2.8, 2.9 millimeters. Converting it to millimeters as measurements. So if we've got about, say, 2.8 minus 0.2, I would go to 2.6 for that one that we want to thread to. I don't know what that extra hole is, but it seems to be a bit smaller. But let's make them the same, because I think it's just 2 different shock mounting positions. It's also, of course, quite arbitrary to try and measure with the pins of the calipers into a hole, because it's not really what they're designed for. It'll give you a close-ish measurement, but of course the thickness of the pins, and especially in small holes, it won't sort of sit right to the actual measurement of the hole. I reckon this is close to 2.4, 2.5. It needs to be threaded into because that's shock mounting bolt. It does seem to have a nut on the other side, so let's measure the bolt. Yeah, the actual thread looks like a 440, so that is what it needs to be. So I might actually make these both the same. And if it's a 440, 2.8, I might start with a 2.6. And the iterative process of this designing is I usually just design it, pick a number, print it, and then test it. And then test all the threads, see if they're too tight, too loose, or test the holes so that the bolts can thread into them. And you're testing all your other measurements and tolerances, and then you come back in here and adjust it accordingly. So let's make both of these 0.2 under the 2.8 nominal. Cool. And then we've got the outside material. So what's that? It's about 7.5. So the outside material on this part is another cylinder. So I'm going to duplicate this cylinder and make it 7.5. So remember, Shift D was duplicate. I'm going to make it 7.5 diameter because this is going to be the actual physical object, not the hole. A bit bigger, 7.6, and the thickness was all over the place. I'm going to make it 8 mil. It's a bit above, a bit below. So let's make our actual object. So that's 7.6, 7.6, 8 mil high. And then the rest of the sort of triangular part, I'm going to make out of a cube. So what have I got there? That's 47.5 and 42 from our center line. We will have 38.5, I reckon. 37.5, 38.5. So I'm going to go Shift A, mesh, and I'm going to add a cube this time. So now I've got a nice little 2x2 cube. Top view. So 7 on the numpad, top view. Okay, now I'm going to do something funky. So you see these objects, we're in object mode up here. I'm going to change the edit mode. So I'm going to highlighting the cube. I'm going to change to edit mode. And you can see this changes how it looks. So now we've got little dots, which are the vertices. We've got lines that join them. They're the edges. And we've got the face. Faces that fill the edges and the vertices. So they're the three fundamental parts of an object. And I can toggle between those three. So these three icons up here. So we've got vertices. So let's select mode in vertex. And if I go to this one, we've got almost over it. So we've got select mode on the edges. So now you see the little dots have disappeared. But if I click on an edge, it highlights it. So now I can select all the edges. And if we go to the third one, that's the face. So the face select. So now if I click on a face, it actually selects the face. So it doesn't select the edge, doesn't select the vertices, it selects the face. So this is edit mode, and you can select what you want to manipulate. So first thing I'm going to do, so this will become destructive modeling, where I'm going to change this cube into a different form of itself. So it'll no longer be a cube. It'll have all the same vertices, edges, faces, but I'm going to change where the positions are. So it'll like kind of, destroy the cube. You can no longer call it a cube. It's just an object with lots of vertices, edges, and faces. So I'm going to press the A button to select all. So you can sort of, with your mouse, you can select. So see here, I can select vertices, because I'm in vertices select mode. And then if I hold down shift, I can select more vertices. And I can select this one. And I can go around the back and select this last one. So hold down shift, drag and select. So see there, I've got all my vertices selected now for this object. And when I'm in this edit mode, I'm not interacting with these other objects. I'm only interacting with the one I'd selected in the first place. So you select it, you go into edit mode. So you can select them all manually like that, or if you press A, the A key for Apple, it'll select all vertices, or basically all vertices for that object. 7, go to top view. Now I'm going to grab, so G for grab. I'm going to move the whole object effectively. I'm going to move it in the green y-axis. So I'm going to hit Y. So see now it's just moving in the y-axis if I move the mouse. And I want to move it 1 millimeter in the negative. So I press 1, so it's gone positive. Now I press negative, and it's gone into the negative. I'll click, so it drops it, and that's where it's positioned. So what I've done there is I've moved it in relation to its origin. So see that little yellow dot? So the red and white's not the origin, that's the cursor. But that little yellow dot is the origin. If I will temporarily just move the cursor for you. So I'll get rid of the cursor there. I'll go back to this object, get that out of the way. So now I can see my little yellow dot there, which is my origin. There's a couple of ways to do that. Another way to do it, so I'll do an undo. So I've gone back to, you can switch between object mode and edit mode by pressing tab as well. So it's a shortcut. So up to you. After a while, I find tabs very quick and easy. But if you forget that initially, you can select it from the menu here. So edit mode. Yeah, so tab toggles between. Yeah, so if I tab into edit mode, go to top view. Because what I want to do is I want to get my origin on this face and move it further actually, so I can sort of manipulate it. Another way to do that in general is I might just select these 4 vertices. So see, the other ones are not selected. So I've selected these 4, and then I can go up to my. I want to move the cursor here. So if I go Shift S, it brings up this menu. So Shift S for Sam, and then I go cursor to selected. So I've selected those 4 vertices, which effectively the center point of those 4 vertices is the center of that face. So I go cursor to selected. So see how it's moved this cursor back here because I've moved it away before. So now I've got my cursor right on the center of this face. And to go further, I go, well, actually, that's nice, but for this, I actually want it on this edge. I want it in the middle of the edge. So between this vertex and this vertex is the middle. So I'm actually going to do that again. So Shift S, cursor to selected. So let's move the cursor from over in the center point of the face to the center point of this edge between the 2 vertices. And then I'm going to tab out of edit mode back into object mode. So now, nothing much has happened other than I position my cursor at this point. You can see the little dot here, the little yellow dot is still the origin of this object, so that hasn't changed yet. So what I want to do is I want to put the origin to where the cursor currently is. So before I do anything else, before I move anything, before I mess with it, I'm going to go up to Object menu, Set Origin, Origin to 3D Cursor. So that's going to move the origin for this object to where the 3D cursor currently is. So I'll click that, and you can see that little white yellow dot has moved to where the cursor is. Okay, so now I'll go back to top view. So you can see the location of my little cube now is -1 and 1. So I haven't actually moved the object. It's still effectively, right in the 0 position of all the axes, but my location is actually not zeros anymore. It's -1 in the x, which is from sort of here across to -1, and it's 1 millimeter in the y, which is up to here. So now I want to go right. I want that back at the sort of center point of my creation. So I'm going to change that back to 0. So it moves the object to 0. I'm going to change that to 0 as well, and it moves it there. So now what I've got is this cube. Its origin is right at 0, 0, or 0, 0, 0. And this is the part where planning this out I can't explain how you go about this for each different piece of object that you're trying to design. This is just something you'll learn as you do it more and more. And you'll see why I'm doing this as I get further into the designing of this model. It'll hopefully become clear. So now I can do a few things. One is I want to make my actual components I want to make it 8 actually. I want to make it about 8 millimeters. So let's make this in the z-axis. I'm going to make it 8. And this guy here is also 8 millimeters. And I don't know whether it's a quirk or just a correct behavior of this whole objects sort of integrating with each other with the Boolean modifiers. But down the track, if you have these multiple objects Boolean connected to each other, or minus from each other, I found that the vertices are in exactly the same coordinates, x, y, z, it causes the object to be not manifold once we move it out to the slicer. So in here, in Blender, it'll look perfect. And for all intents and purposes, it's perfectly reasonable. But for our purpose of then exporting the object into an STL file and manipulating it in a slicer and having it being manifold, which means it's got no missing vertices, or all the faces and all the edges and all the vertices are all connected properly, which means it's manifold, which means it can be printed. So that's a key aspect of getting our model to be of sufficient quality, I guess you could say, for this purpose. And if we have intersecting points between two different objects that are exactly the same, I don't know why, but it causes issues with the object not being manifold. So you'll get errors later down the track in the slicer. So what I do here to preempt that, or to avoid that, excuse me, is I make it slightly different. So once it's printed, it's like absolutely, the order of magnitude is extreme. So if I make this guy 8 exactly, I'm going to change this one to 8.02. 8.02. So that's literally 2 1/100ths of a millimeter difference. So in terms of an end result, it's irrelevant. It's absolutely order of magnitude and what's the word? Can't remember. There's a really cool word of its of its criticality, of whether that matters or not. So yeah, in the scales that we're dealing at, 0.02s makes no difference to your final model. And so I'll do that for now, and I'll hopefully show you why that is the case later on. Okay, what have we got here? Okay, now let's scale this out. So I'm going to press S. So I've selected my little cube here. I'll put it on an angle so you can see it. I'm going to press S for scale. So see here, we can scale it. I don't want to scale it in the x-axis. So if I do Shift, sorry, I don't want to scale it in the z-axis. I want to scale it in the x and y axes. So if I do Shift Z, see how it now, Shift Z is like not a Z, so not Z axis. So now I'm only scaling it in the X and Y axis. So I've got my little object here. So what do I want to do? I want to kind of bring it out to somewhere. It's a bit arbitrary, so let's make it there. How far down is it going to go? It's about 38 and a half. So from the center line of those cylinders in the Y, I'm going to make this 38.5. So that's, there we go. So that's the full height. So it's going to go from the center line of the holes down to the bottom surface. And then the width out, so this whole bottom base of this component is 47.5. So I want this to be at 47.5. So each one of these is 10 mil. These squares, got 10, 20, 30, 40. So what I can do here is edit mode, select these two, and grab it. So G for grab, and see how it's all over the place. I want to constrain that to the x-axis. So now it's moving the x-axis, and that's about 40, and that's about 7, and that's about a half. So I'll just drop it there for now. Top view, and it's actually not. So grab X, so let's move it back. So 47.5 is there. So you can zoom in. It doesn't have to be super perfect. Yeah, again, we're talking, was it materiality, I think was the word I was thinking of. Is that the right word? Materiality. So in terms of, I guess, materiality of how close this is to 47.5 compared to how it's going to print is just close enough. So yeah, so 10, 20, 30, 40. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. So 47.5. I don't usually use them. There's a measuring plugin, which I'm not going to show today. I don't really use it. There's other ways to verify that you've got that about right. Is in this case, because it's the widest point here. So the full width of this object is now 47.5, so spot on. So it's got me that bit. Now, what else have we got? I'm going to want to join the dots soon. So another cool view mode I'm going to show you now is the sort of wireframe versus solid. So you can see these objects are looking solid to us at the moment, so I can't see through them. So I've got a couple of different options here. One is I can do like an X-ray. So this is my shading sort of mode, the solid circular icon. So when I'm in that mode, I can click on X-ray, and you can see here it's changed a little bit. So I can kind of see through the object like an X-ray can, which is kind of cool. So that definitely helps once you start getting more complex shapes and you want to see where they all are and how they're interacting. And then another mode here is wireframe. So this little circle icon with sort of lines through it, like a frame. So it's a wireframe mode. So if I click that now, so see it's totally changed. So I can only see basically the edges, kind of like vertices and edges, but it's pretty much the edges of the object. And it's completely see-through. So all of these modes are very useful for as you design and come in handy for different reasons. So just for now, know that they're there, and you can just click and unclick them as desired. Cool. So I've now got that shape. I've got a little bit of a tucked in sort of inner curvature. And the way I do this is probably would be considered a bit clunky by a lot of designers, but I like it. And it keeps me the flexibility to not have to recreate objects. So what I'm talking about is basically the destructive versus non-destructive modeling, or a hybrid of the two. And pretty much most things are a hybrid of the two, with favouring the non-destructive with a small splattering of destructive as needed. So you can see this guy curves in a bit. What's a good line to pick? So the width there, so that's about 12.5 at the point where it is, so 5mm down. Cool. So I'm going to grab the cylinder, duplicate it, and I'm going to move it in the y-axis -5mm. So Shift D for duplicate, Y for y-axis, 5 minus. You can do 5 minus or -5. It doesn't have to be in one particular order. And then the minus just keeps toggling between. If you keep pressing minus, it'll toggle itself between positive and negative. And I've forgotten that number. 12.5 or 12.6. So this one I want it to be half that, which is 6.3. So it's oh, I've put this in the wrong spot. It should be 4 and 8, which lets me demonstrate why it's so easy to change things. So I actually made this too big, as in too wide. So this one's not at 8, this is meant to be at 4, so I just changed that to 4. And if I want to actually move a few things, so I can grab this, I do Shift and click another object. So see now I've got 2 objects selected. So you can click and drag objects, or you can select one, hold down Shift and click another. And then if you click another one by accident, you can click it again, it'll unselect it. So then I'll grab these guys. I want to grab, G for grab. So see now that can move. X-axis 4 minus. I actually want to put them back there. Click or enter to drop them. And then this guy, 5mm down, and 12.6 divided by 2 is location is 6.3. So this guy here is going to actually cut out the curvature in my object. So I'm going to make him a bit longer so it extends above and below the cube object. What else have I got? I have got another, I don't know the radius of that one, so we'll probably work that out as we go, just to make the radius look nice. It's pretty small, so it's probably about 2 or maybe 3mm. So now I've got another circle. How big's he? He is maybe 6mm diameter. So let's duplicate this guy again, and How far down is that? Center. The top of that curve is going to be about 8 mil down from the center. So I'm going to move this one back to the center. Oops. If you make a mistake, Control Z. Same as lots of software. Control Z is your friend. super useful to undo all your mistakes. So this one, x-axis, I want it to be 0. And again, for what I was saying before, I'm going to actually put this at 0. I'm going to move this one to 0.02. And I'm actually going to move my whole cube object here. I'm going to move him to 0.01, just slightly away from the y-axis. Wow, excuse me. Ugh, hay fever. And again, that's that whole sort of stopping vertices exactly intersecting with each other, which caused me my problems. So while I'm about this, I might move the y-axis to minus 0.01 as well. So let's just move it down a fraction. So you can't really see a difference, but if you zoom in massively, yeah, you can see here that I'm 0.01 of a millimeter away from the 0 origin. But when you zoom out, like this whole object's, going to be probably that big in real life to make this. Yeah, those tiny measurement differences are completely irrelevant. Another good little shortcut key. Blender's all about shortcuts. So if you don't like shortcut keys or remembering keys to find things, you'll either not like this, or you'll have to just gradually learn and adapt to it. So just say this is quite a simple model at the moment, of course, but let's say I've got a big, massive, complex model, or I've lost where I am. You can do a couple of things. One is in the View menu, you can do Align View, and then you've got a few options here, like Align View to Active. So if I've got it selective, I can click that. I could center view to the cursor. So if my cursor's on my object or at 0, I can center it to that. So let's try that one. Center view to cursor. So now it brings me back to my model. So if you get lost, sometimes like see if I zoom out and I'm lost, I'm like, oh my god, where am I? And if you're zooming in and out and you can't find yourself or can't find your model, you can just go, I think Shift C works as well, Shift Center, Shift C, but you can always go View, Align to Cursor, and you can see the cursor. But even see here, we're a bit zoomed out. Just say you're lost still and you don't know how to get back to it. So just say I'm like here, pressing the dot or the delete button on the numpad. So just the period, the dot button. That can also get you back to your that can get you back to your selected object. But see, I had nothing selected, so it didn't actually do anything. But just say I'd selected this guy, and now I'm lost. I'll press the dot, and see I pop back right to my selected object. So that's another good shortcut to write down and remember eventually. What I did was write down a lot of the shortcuts. Got a list up there or something, and after a while it becomes second nature, but occasionally you forget things, so it's good to have a quick reference guide for yourself if that's how you like to work. Cool. So what was this one? I had, that's about 6 mil. So I'll make this guy 6 millimeters, and he's going to cut out, so he's 12. And I wanted the top of this cutout to be 8 millimeters from that origin point. So I can do this two ways. One is I can just, I can select him, and I can grab him, and I can move him in the y-axis, and I can just line him up to about 8 millimeters here. So it doesn't have to be perfect for this purpose. Another way I can do this is I can edit this cylinder. I can select this sort of top of the cylinder, I guess, in this view. And again, do the shift cursor to selected. I get my little cursor. Tab out of edit view, object, set origin, origin to 3D cursor. So now my little yellow dot for this object has gone to that point. So you can see it there. And another way to do this, now I can see my Y position is this 8.01. So again, that would be perfectly fine for this purpose. Doesn't have to be that accurate. But what I can do is just position it to -8 mil. So it's a slightly more accurate way to do it. And I'm slightly off the y-axis, so 0.02, so I don't break the mesh. So that's going to form my cutout there. And what else have we got? That's 38. 40. Yeah, so the width at the bottom, I think I've got that double the amount it should be. So 47.6. So this position, these corners, actually want to be 47.6, or half of that, because that's the full width. I'm only modeling half because we're going to mirror it. So I want to move this 47.6, that's 23.8. So I'm going to grab x minus 23.8. Tab out of edit mode. Okay, is that hole in the right spot? So that hole, 12.5. That one should be about 6.3. 1, 2, 3, 4, 5. So I've got the center there. So I want the edge of this circle to actually be here. Yep. So my diameter is 1.3, so I can tab in edit mode, select it all by pressing A for all, grab X 1.3. So I'm actually putting my, so effectively I've done two things there. I've moved the object and I've effectively put the origin of it at that side point rather than the center. So I can now tell it, yeah, I want it to be 6.3. Just lets me position it a bit easier. Which isn't even, oh, yeah, that's where I want it. And then vertically, so down from the, down from the x-axis, I reckon about 5 mil. I think that's where I've got it. Yep, so I'm -5 from the x-axis. So that's the cutout there. Okay. Now I'm going to do some destructive modeling on this, what used to be a cube. So I've already destroyed it. It's no longer a cube. It's just a shape with its vertices in different positions. So what I'm going to do is I'm going to grab all these ones, and I'm going to, so I'm going to go G for grab, move them in the y-axis, and I'm going to move them up to kind of here. So I'll make this sort of top surface, grab Y, just inside. I'm going to put it just inside the cylinder. I don't want the vertices to clash. I'm going to grab these ones, and I'm going to grab them, move them on along X. So grab G for grab, X for x-axis, move it. So see, I'm zooming to the cursor. So we set that that zoom setting earlier in preferences. So wherever my cursor is where it zooms to, which is kind of handy. I'm going to grab this X and put it here somewhere. So see here, it looks like it's miles away from the point. That's fine, because we're zoomed in so massively that when we zoom out, we can see it's just so close it doesn't matter. Now I'm going to do something new, which is I want to actually put more vertices into this side, onto these edges, because I want to sort of bend it around all of these circles and make my shape. So I'm going to, so I'm in edit mode, I'm going to actually toggle to the edge mode. So the shortcuts for these is just, once you're in edit mode, the numbers 1, 2, and 3, just the normal numbers on the keyboard, not the numpad. 1, 2, and 3, so where am I? I've got this guy, yep. So if I press 1, I go to my vertices mode. If I press 2, I go to my edges mode. If I press 3, I go to my faces mode. So you can see here, if I click on the dot, that's actually just one face. Edges mode, if I click on an edge, hold down shift, I can select multiple edges. And then if I hit 1 or click up here, I select vertices. So what I'm going to do for this purpose is I'm going to select edges. So I want to select, so I go 2, like click here or press 2. I want to select these 2 edges. And then once I've got those selected, you can see they're both selected, I'm going to right click and I get this context menu. And I am going to click subdivide. So it's basically chopping them, dividing them into more pieces. So at the moment, so what that means is, like at the moment I've got one edge here and one edge here. So that's just one piece all the way from this vertice to this vertice. So I've just got the one edge. So I could select one, but in this case I want to select 2, right click, subdivide. So now you can see what's happened here. I've got this new edge, and if I hit number 1, I go back to vertices. So see, I've got vertices here, go back to 2. So now if I click on this edge, the edge stops here. So I've actually got 2 edges where I had one before. So, subdivided. Right. So what this now lets me do is I'll press 1 to go to vertice mode, select these 2 vertices, and I'm going to put Shift Z, so not in the Z axis. So see, it gives me the Y and X axis position. So now when I'm moving it, I'll do that again. So I'll just, if you do escape or right click, so see I've got it selected. If I want to cancel it and go, oh, wait a minute, I don't want to do this, I can press escape or I can right click the mouse. And that'll basically, it's like an undo for that purpose. So it goes back to where it was. So if I select these, I'll actually go grab and see I can kind of go all sorts of ridiculous places with this in all axis. So if I go Shift Z now, see now it's just moving in the X and Y axis only. And that's what I want. So that demonstrates that. So I'll go right click. 7 is on the numpad, back to my top view. Right. So now I'll grab them, Shift Z, and I want to drop this. I don't want to drop this. It's pretty much straight, so kind of there. So grab, Shift Z, I want that to be there. Right. And now I'm going to go back to edge mode, select these, do the same thing again, right click, subdivide, back to vertice mode, got another split, grab, Shift Z, I'm going to go up to the top of this circle, grab, Shift Z, put him about there, and now, same again, 2, select, right click, subdivide, 1, select the vertices, grab, Shift Z, and I'm going to put it somewhere on the side of this circle. So now, see, I've got this shape forming. So I want to come from this point. I want to go up and then do a nice curve around here, because eventually this cylinder is going to be a Boolean operator, and it's going to chop out this nice curve from my cube, from what was my cube, from my big blocky weird shape object. So I want this to come nicely into the curve. So again, this is my, I don't know, crazy way of doing things. Other people might do it the same way. There might be better ways, there might be different ways, I'm not sure. Again, this is just my way. So take it or leave it sort of thing. If you're learning, you can do it this way. If you find a better way that works better for you, then go for it. And I would love to know what that is, because I'd probably like to try it to see if my crazy way is is stupid or has limitations or has issues. Always learning. So I want this to come in here, so that's close enough. So that'll give me a nice curve there. So hopefully you can sort of see what I'm trying to get to. This shape is maybe coming together. So I've got this circle here, but there's a big sort of inner cutout I need to do. So I basically need another cube to sort of make a cutout in here, and we'll have another circle down here to make it a nice radius. And again, this is definitely not the way people design for like CNC type work. This is my very specific way of doing 3D printing. If you want to convert an object to something that can be cut on CNC machine, this doesn't really lend itself, and probably ultimately won't work. Most CNC people will not accept this result as the result from this modeling as a viable file. It needs to be designed in a step format, or designed and then in a way that can be exported as a step file, is what the CNC machines will understand. You can make a step file by tracing and replicating an object created this way, but it's definitely, I haven't found a good way to convert it yet. I found ways to convert things, but it's not great. So yeah, just another thing to keep in mind if you're trying to design an object for CNC, like carbon, aluminium, or steel, etc. There'll need to be an extra step, so to go from this model to something that can be exported to the machine step code. Cool, so I'm going to duplicate this circle, and not in the z-axis, I'm going to keep it the same height. I'm going to pop it down here somewhere. So we're going to need to work out where this goes exactly. So my wall thickness is about 5 mil, and that's 5.2. 5. It's probably all about 5 actually, so that make it easy. So I'm going to add a little object here, cube, and I'm going to do a similar thing. So I want to make that corner set origin as a 3D cursor. So same process as I showed before slowly, I just did it quickly. And then I'm going to grab it, and I'm going to put it here somewhere. Doesn't matter too much where, I'll just put it near this point. So pretty much at the pivot point here. So this is not going to be part of our model, but it'll give me a good reference. So what I want to do here is scale it in the y-axis and rotate it in the z-axis. So rotate I haven't showed. So the pivot point's here, like the origin point here, which will become a pivot point. So I press R, so the R key for rabbit. R will rotate it, and it'll rotate sort of all sorts of places. So if I want to rotate it in the z-axis, I press Z, and then I can rotate it to line it up with my actual object, which I got pretty close there. So you can, doesn't have to be perfect again, but close. So that looks pretty much spot on. So when we zoom out, it's going to be more than close enough. And then I'm going to scale it. So S for scale, and so see what's happening here. So if I press X-axis, it's going to scale it in the X-axis, which gives me that sort of behavior, which for this purpose might work, but what I want to do is actually scale it based on its shape. So if I press X again, so basically pressing X twice, so see this just lets it scale in just that directional x-axis based on its orientation. So if you press X1, set just x-axis based on the view. If you press X again, or the axis again, so in this case X, it'll scale it based on its orientation, which I've already changed. So this number here, so I want this X dimension to be 5 millimeters. So see, I've got a Z rotation here. It doesn't really matter what this is. It's just whatever I lined up here. I made it 5 millimeters, and that'll give me a guide. And here, like, this sort of thing doesn't need to be perfect. So let's scale it, SXX, and I'm just going to bring it out to about here. So just give me something to line up to for the time being. So this guy, I want him to be 5 millimeters from the bottom. So I'm going to actually put my origin of this one. So selection to cursor, tab out, object. So you can see a lot of this stuff is just repetitive. So once you've learned all of these little bits and pieces gradually, it's pretty much just repeating the same steps, same sort of techniques, same processes over and over for your purpose. So now I've set the origin to here. I'm going to actually grab it, move it down to about there, getting sort of roughly close. It's close enough. Where am I? Minus 38.5. So minus 38.5 is that position. I'm going to grab Y. Oops, I pressed 2 keys. You can press escape to start again, or you can press backspace. So I want to go 5 millimeters. Enter. And I want then this to intersect with my reference here. So I'm going to grab this in the X, so GX, move it across until it's kind of about there. Now I'm going to add another cube, but I can just duplicate this object because it's going to be similar. So I go Shift D, duplicates it, Shift Z, so I want to move it not in the Z axis, and I'm going to drop it about here. A lot of this will probably look a bit weird what I'm doing. It'll start to make sense when I do all the Boolean modifiers, which is the super cool bit. And after a bit of editing of this video, a lot of this I might speed up, so it's not too boring for you. So what I want to do here, so I want to drop this guy back here. I've already got the right angle. And again, I'm kind of just going to move the points around. So I'm going to scale, S for scale, Y. So that scales it based on its orientation. I'm just going to bring it back up here somewhere so that it's inside this is my cylinder. And this is just inside a little bit, so it's not going to clash. So at the moment, I've still got pretty much a cube. I've changed the length and dimensions, but it's kind of a cube, so it's partially destroyed. Now I'm going to really destroy it because I'm going to go to edit mode, grab these, not Z, and move them down to here. Grab, Shift Z, put that there, and I need another point. Cool. Subdivide. Grab, Shift Z, and move it just outside the shape because this is going to be a cutting out object. Nothing you can do here to line up the, make it sort of parallel straight line kind of thing. These points here have a Y value of that, so you just copy it, doesn't matter what it is. I think it does. Grab Y, which one is it? Combination of both, a bit tricky. yeah, let's just line this one up by. Sometimes you can just copy the values and set it, but it depends on the orientation of the part. So where's that one? That's like 5. Yeah, so we can just grab Y, put it about there as well. Cool. Alrighty then. So this cutout is going to be scale Z. So let's make that about 9 or so. As long as it's bigger than the actual object we're cutting it from. Cool. Okay, what have we got? There's a hole in the top. What's that for? There is same thing, probably a 440 hole right in the top. How deep does that go? Ten mil. Copy another one here. Duplicate X. 0.2. Okay, now I'm going to rotate this around the x-axis by 90 degrees. And I want the whole depth to be about 10, so I'll make that about 11. And then grab it Y. And that can be a little bit more. What else we got? We've got a hole down the bottom corner as well. So that is about 40. Just over 40. So about 40.2 divided by 2, so 20.1 mil. So I've got another hole there. Which is like that one. So I'll duplicate Shift D, duplicate that. Shift Z, 20.2. So that needs to go at 20.2. And it goes right through the object. I might modify that later on, adapt it for a bit more strength, but initially just replicate the part. So just move that up so it cuts right through. Yeah, it's very close to the edge. Only a few mil there of material. So I might beef that up later, but that's the sort of iterative, evolution of a part. You start somewhere and then improve it until you deem it is of adequate quality that it does the job. Cool. There's also a bit of a cutout in the bottom here. There we go. So that is, it's about 9.6. And from about 8 mil, it goes down about 3.4. So if I go down here, and another thing you can do is, not critical, but just make it a bit more, make the process sort of flow a bit more, is you can go cursor to selected. So I selected those vertices, move the cursor there, and then tab out. So it doesn't always work, but what that should do is my new object. So I go Shift A to add an object, mesh, cube. Yeah, so that's good. It usually should do this. It'll spawn the new object at the cursor, so it just makes it convenient, because if the cursor's somewhere else, the object will appear somewhere else, and you've just got to move it. But that just makes it slightly more convenient. But really, neither here nor there in the big scheme of things. I'll put that at 0. The width I'll make, well, I measured 9.6. So this is a cutout, so I'll just make a sort of full object. Scale it Y, so it cuts out that full bit. Now the height of it, so if I go down here, I press 1 on the keyboard, it gives me the side view from the down the Y-axis. So this is too high, so I'll go Tab, everything's selected by default, but just A to select just in case, grab Z1, so that moves it up. So now that bottom surface of my cutout, I want that to be about 3.4 above the, or from the edge. So the whole thing's going to be 8mm thick, so that's 4. So I'm going to grab Z 3.4. And then I'm going to scale this, S in the Z axis, scale it up a bit, so it chops out a section. Now all of this chopping and Boolean modifiers probably doesn't make sense to you if you haven't done that sort of stuff. Okay, so now let's make it make sense. So I've created pretty much all my objects and bits and pieces of this part. Doesn't really matter if it's, you can do this in a whole lot of different orders, but it kind of just evolves organically from the way your brain sort of processes and thinks about things. So today this is the the sequence I've done this in. So now let's get into the Boolean modifiers. So what we've got here, so let's move this down. So you can see up here we've got a collection. So now what I do, the way I structure this, it's totally up to you, but here's the way I do it. So I'll give this a name of the object. So let's say I've got Lucas Agitator. Uh, 1/10 scale. So that's my high-level grouping. Right-click New, and then my object here is Shock Tower. And then, so you can create folder structure here as desired, whatever makes sense to you, however you sort of evolve and decide to structure your objects. But the pattern I use is, you can have like the sort of high level, what it is overall. If you're doing many components, I usually end up doing pretty much all the components in one file. So if it's, like my current RCX 37 model, it's a whole car, every single part is all in one Blender file. You do need a decent GPU to sort of manage that once you get to a certain number of components and objects within one file. But so far I found my, it's not a brand new video card, GTX 1060. Had it for a few years, but it's a pretty good one. That does the job for this purpose very nicely. So yeah, that's why I end up doing it. So the whole file you can name as your thing, your overall car or your model, whatever you're making. And then within that, so you can have this parent folder if you want or not, doesn't really matter. But then have a parent folder for each object. So I try and keep it, don't try and make two objects and keep all the parts in one folder. So what I do is, create your folder name. So make it descriptive. I do keep them in alphabetical order as well when there's multiples. So here we're only got the shock tower for today. But if I made a bumper bar, I'd put that alphabetically before shock tower. Because then after a while, if you get lots of components and you put them all alphabetical, you can just move the drag and drop the folders as needed. It won't automatically put them alphabetical, you just got to move them. But that does let your brain go, right, shock tower, so scroll down, get to the S, and you can collapse all this stuff as well. So I'll just demonstrate here. So if I click this, it collapses. So if you've got lots of folders, you can sort of collapse all up so you can see easily the high level. And then, so under each of these component ones, I create two folders. So go new twice, and I create one called materials, and then I create the second one called cutouts. So also keep in mind that all of these folder names and all of the file names are globally unique within this Blender file. So if I created a folder here just called materials by itself without this shock tower prefix, and then my next object, I create another one called materials, it'll go, oh, that's a duplicate name. It'll automatically change it to materials.001. So you can see here when I've been adding cubes and I haven't renamed them yet, which I'm about to, you can see it's automatically incremented. Your first one is just cube, second one is .001, 2, 3, and so on, and then cylinders 1, 2, 5, 6, 7. So that's the default naming sort of process that Blender does for you. But it's very good to give all of these objects proper names, and as you build bigger objects, you'll see why. Which is if you've got 150 objects called cylinder 1 to 150, it's not very human friendly when you're starting to look at things and clicking on objects and trying to work out which one sort of belongs where. So even though it's in folders, I still name the things like with a, you can use whatever notation or characters you want pretty much, but dash or whatever. So I'd go like shock tower dash materials and so on. So all of these objects need unique names. And you can use the one, .00123 sometimes helps if you've just got a bunch of things like these cutout cylinders. It doesn't really matter what they are. You could just say shock tower hole cutout 1, 2, 3, stuff like that. I do often use the type of hole naming. So, for example, let's start here. Cylinder. So here I would go shock tower. And this is an M3 thread, not a hole. So if it's a thread designed for threading into, and then so that helps me with a few things such as it's meant to be a thread. I look at 2.6 millimeters and I go, right, that's good size for a thread. I haven't stuffed it up because if it's meant to be a thread and my size is like 3.1 millimeters, I'm like, oh, wait a minute, that's not going to work. So that helps in that way. And then I'm going to drag this object into my cutouts folder. So you see now I can collapse the cutouts folder because it's got objects in it. And it sort of gives you like a grouping or a categorization. And you'll see soon that you can hide these icons, like an eyeball. If I click, so I've got a folder of cutouts. So look at this selected object. I've only got one in there now, but if I want to hide all my sort of cutouts, I can just click this eyeball and it disappears. So I click it, reappears. So that gives, so if I want to hide all my sort of objects that I've used to cut and add to objects, once I've got the sort of finished product, which we'll see shortly, it makes it very easy to hide and show them all without clicking onto each one, because you don't want to be hiding and showing individual objects when there's tens and hundreds and thousands. Or tens is probably okay, but when there's dozens or hundreds or more, that's not feasible. So grouping them into folders lets you then hide and show the whole folder effectively, which is super cool because you want to have a nice clean view when you've got finished components. And all that sort of stuff becomes apparent as you sort of do this and progress through it. So M3 thread. So I could do things like I could call this 001. I could call it, inner, outer, give it a more descriptive name. It's sort of up to you how explicit you want to describe them. For now, I'll call it 001. Actually, no, let's call it inner. So it's like shock. So you can go like shock mount inner, as opposed to 001. So 001 is unique but meaningless, or you could give it shock mount inner. There is a maximum number of characters that these names can be, which isn't heaps. So just keep in mind that this sort of verbose naming, I'll keep typing stuff. See it? Yeah, there. So 1, 2, 3. It's stopped. So it's quite long, but not infinite. That's the longest file name you can have, which is enough generally, or you just chop it down otherwise. So I'll copy that name. I'll call this whole, instead of inner, I'll call it outer. So this one here is it shock tower? So this is just the curve cutout. And then we've got, so this box here is like in a triangle cutout. I'll copy that name, and this can be curve 1 and curve 2. What's this one? This is lower notch cutout. So you can grab all these files, like shift and select, or select them one at a time, drag them into the folder. So you can do that sort of as desired, when you want to. We've got this reference cube. So this one, I'll probably just call that the sidewall thickness reference. So it's kind of a material, I guess you could say, but check that there. This cylinder here. So this is actually like material for this hole. So I might copy that name. And M3, so it's not a thread, it's material for shock mount outer. Put that in the materials folder. What else have I got? So this is an M3 thread. So this is the center shock mount. So keep the naming structure. So shock mount, center top. And then this one down here is the shock tower mount. So this is M3 thread for the mounts. And then the shock, so this cube. So there's a couple of ways you can do things. The sort of, I guess, simplest standard kind of logical way is just to pick one of the objects and say that's my actual shock tower object. So this cube could be the base shock tower object, and we'll add and remove everything, all these other objects from it, like all the Boolean operators from it, which is fine for most cases. Probably 99% of the cases that'll work nicely. The only sort of scenario I've found where that's a little bit annoying is if I decide that this whole sort of, I've already destroyed this cube, I've made it into this shape, so all these points are everywhere. I've already made this shape. If I decide for some reason, probably not in this case, but in a hypothetical, that oh, that object's just all wrong, I want to start again, which I can do. So I can just delete that, add another cube, start again. But then I've got to add all of the Boolean operators back to the new object again, because they'll be lost if I delete this. If I add them to this object and then delete them, then they'll be gone. So it's kind of annoying, inconvenient. If it's a very complex object, there'll be lots and lots of Boolean operators, and that would take a lot of time to sort of recreate for no benefit other than getting you back to the square one sort of thing. So what I often do, or what I sometimes do, is I create like a little, just add a cube and make it very small, and it sits inside this main area. So it's kind of a dummy object that I then add all the Boolean operators to, including this sort of main cube object as just one of the Boolean operators to add it. So therefore I can delete that as just another random object and recreate it if I want to. Whereas my core actual component with all of the Boolean operators attached to it can stay there. I don't have to delete that. So let's do that just for demonstration purposes. So I just put the cursor here, and I'll add another cube, and I'll grab this guy and I'll put him in the sort of blank spot, just an arbitrary blank spot here. See how, and it's going to be fully inside the final product. So he can just sit there. So this cube is in my shop tab folder, yep. And this cube here is going to come into my materials, and this is the main shock tower shape. So that's just another object. Yeah. And this one, so shock tower, I'll call this one shock tower. So see that. So now you can see the structure. So we've got our shock tower, and our looks edge, so top level. So expand, shock tower, and then if I've got lots of objects, there'll be a big list in the tree of all my different objects, and manually put into alphabetical order. So then I can expand out one, such as this one, and then just say I want to hide all of my materials and cutouts. So I go, right, this is my shock tower object. At the moment, it's nothing. It's just an arbitrary random cube that's meaningless. So now what we want to do is add Boolean operators to it. So I'll, at this process, we'll unhide so we can see everything. So now we go down to this spanner. So this spanner icon is the modifiers. So I click on here, and I can go add modifier, and you got a bunch of different categories of modifiers. The ones I'll show you today is under the generate category, Boolean, and also mirror. So there'll be heaps of Booleans for all of these, and we'll have one mirror at the end to mirror this whole thing to complete the component. So to start with, I'll add a Boolean. So I click on Boolean. So it gives me this little window here with my parameters and configuration for that Boolean modifier. So I'm going to add heaps of Booleans, like one for each of these other objects that I need to add or subtract. Difference is the subtract, the word I couldn't remember earlier. Union is to sort of add them, combine them together. And intersect is where the space where two different objects would combine is just the intersection, is what you would get. Pretty much all of this is going to be a couple of unions and most, was it? Yeah, probably one union and many differences for all of these, and then a mirror at the end. So once you've got one here, you can add heaps more. So I'll show you another shortcut, which is Shift R. I hope that's correct. Usually just after a while you just do it sort of instinctively, but when you're first learning, yes, I'll go, yeah, Shift R. So that just Shift R repeats, so R for repeat. Shift R repeats the previous command you did. So the previous command I did was to add a Boolean operator. So Shift R repeats it. So now I've got 2. And I can just keep doing that. So I do Shift R, Shift R, Shift R, Shift R. And if I toggle the stack, it'll collapse them all. So you can see I've got heaps. But my Shift R is now the toggle command because that's my last command. So you can do that, or so I find that's convenient if you know you're going to add a whole bunch. It's just a quick way to do it. Otherwise, you have to go back into add modifier, generate Boolean, and you can add another one. There is what I do as well is instead of going through that few clicks of going add modifier, navigate to the right folder here, and go up and find the one you want, like Boolean. Instead of doing that, you can add them to a shortcut menu, which I have totally forgotten how to do. So let me Google that for a sec. Yes. So yeah, all of these sort of commands and stuff, super easy to Google. Just type in Blender how to and then search your thing. And there's all the information's there on the web, of course, as it is these days, to tell you how to do things. The hard bit is to know what to Google for sometimes. So if you don't know what you want, then it's difficult because you don't know what to Google for, and that's where general learning and watching these sort of videos and trying things yourself, and you'll gradually learn the ways that things are done, and then the Googling of how you want to get to somewhere becomes more intuitive, I guess. Maybe not obvious, but you sort of start to work out how to what to Google for to get the right answer that you're actually after. So what I do is add them to a shortcut, which I've already done. So if I press Q, so it's quick favorites. So yeah, pressing the Q button brings up this little shortcut menu, and I've added these 3. So Boolean, Mirror, and Array. They're the ones I use most commonly. And then so you can go like Q and then B. So if I go Q, B, see it adds another Boolean, number 8. Q, B, I got number 9. And then if I go Q, M, so you can see down, oops, that didn't work, Q, M. Maybe the mouse needs to be here. QM gives you quick shortcut, so go Q and then mirror. So I've added a mirror down here. I'll delete that again because we'll add that. I'll show you that in a bit more detail when we add it later. So to get them onto that quick favorites menu, you would go into the actual normal method like add modifier, generate, and then say Boolean, and then you right click. And because I've already added to quick favorites, it only gives me the option to remove. So let's just remove that from quick favorites. So now if I do Q, see there's no Boolean on my quick favorites. So now if it's, by default there's none there. So the first time you do this, you go generate Boolean. So don't left click, so right click on it. And now we've got add to favorites, to quick favorites. So you just click that and then Q, and then you've got it there. So easy. So then now, you can just go QB, QM, or QA for an array. Won't go into arrays for this video, but that's another one that I use reasonably commonly. And then that just adds these modifiers quickly. Saves a few clicks. Cool. So now we want to configure the modifiers. So my main object is this little tiny cube, and we're going to add the big cube. So there's 2 ways to do it. One is you can click on the eyedropper and then go to the viewport and actually hover over and make sure you make sure the correct name of the object you want. So if you go to another one, see this is M3. So you have to make sure you hover over and get the correct name, which is where the naming helps again. And I want this main shock tower shape. So I'm going to click on that. So now we've minus that from ourselves, so it's kind of disappeared, which is a bit weird, but because what we want to do is not difference, we want to do union. But before I do that, I'll delete that again, and I'll show you there's 3 ways to do it pretty much. Another way is you can do similar, so click on the eyedropper, but instead of clicking on your viewport object, you can actually go up and click on the name in this tree list. So main shock tower shape, so you can actually just click on that, same thing, so same end result. And the third way, so I'll delete that again. So the third way is in here, you can just type. So if I know what it's called, or I just look in here and go, yeah, that's my object, but I can't sort of see it on the viewport, or it's a bit complex, I can simply type in here. So if I know it's called something like main shock tower, I can type main, and it filters this list based on what you type, and then you can click on it. So that's 3 different ways to select the object that you want to be for this Boolean operator. Now, you can see the default names as per the objects. The first one is called whatever it is, like Boolean, and then all the subsequent ones, it just increments the 001 counters. So what I do is always copy whatever the name is of it and paste it here as well as the name of the operator. So the actual object that you're using as the Boolean, you make that name the same as the Boolean entry. This just helps you from a human perspective. It doesn't matter for the actual software. But when you've got all these Boolean operators all listed, Boolean 1, 2, 3 means nothing to us as humans, but the name does mean something. So that makes that easier, I've found. So I always do that as a process step. Okay, so for this one, we actually want it to be a union because we want to join ourselves together. And we've got a solver here. I'm not going to go into this, but the default is exact, and the option here is fast. Fast literally does what it says on the cover. It makes the rendering and the processing of Blender a lot quicker. Because when you do get a few objects like this, it's not going to make any difference. But when you get dozens or 100 objects or more, or 100 Boolean operators or more, it gets very processor intensive. And even with a good GPU, it still can take time to sort of recalculate itself. So when you make a change, it has to sort of process all the Boolean operators in sequence, and they do have a sequence. So we'll get to that shortly. But there's a top to bottom here is the sequence with which they get applied, and when you're unioning, like adding or subtracting things, that sequence is very important usually. Sometimes, like some bits don't matter, but certain things that need to happen in the right order. Like if you minus a hole out of a bit of material that hasn't been added yet, that won't work because you'll minus it, nothing much happens. You add the material, you've got extra material on your object, but then the hole won't be there, so that doesn't work. So that's where the sequencing is very important to get right. And each of these entries here can be dragged up and down by this little handle on the right hand end. So it's like super easy to drag them. Way earlier version of Blender, I can't remember which one, probably like 2.7 or 2.8 something, didn't have the drag and drop. It just had little arrows, so you had to click up for every single step, which takes ages when there's a lot of them. So when they introduced this handle to drag and drop, it was amazing. Anyway, you're probably not interested in that. I think it's cool. So yeah, anyway, so I got that added. So now if I hide all of these objects, so instead of having now one little tiny 2mm cube, we've now added this other big shape onto it. So now our actual component looks like this. And if I go back to our shaded view, so we can see we've got this shape. So hopefully that demonstrates what the Boolean union is doing. Because if I go here and I say my viewport, if I click on this viewport, that's basically hiding all. See, this monitor is now blank. So I'll click viewport, the monitor is blue and highlighted, sort of. Yeah, so that toggles. So it toggles them all off. So effectively switches all these Booleans off like they're not happening. So that's our base object. And then if I switch it on, or switch them all on, you can see the result. If that sort of not making sense, yeah, maybe Google a bit about it, ask me, send a comment. I can sort of show or explain it more, but that sort of thing should become more apparent as we go through all of them. So the next one, I'm going to do the same thing. I'm going to click on the eyedropper. I'm going to click on my materials up here, the M3 material, and you can see that cylinder. So I've got hidden. So if I just show that, you can see the cylinders here. All right, so that's my object, but I'm going to hide it. And you can see here, I've added it as a Boolean operator. Copy the name, I'll paste it there. And we can see the default, when you create all these Boolean operators, the default is difference and exact. The fast and exact does have some implications depending on how the objects intersect. Basic, it doesn't really matter. I always click fast to make it process the fastest. Sometimes, if I've got a really complicated object, lots of vertices, and there's some funky stuff going on that I don't understand, sometimes the exact option, just individually, you just flip one of the booleans over to exact, and it might fix the problem. And you can see it pretty quickly because it just renders it correctly or not. So just keep that in mind for now, but that's all I'll say for that at the moment. Just set it to fast until it becomes an issue. And that's one of the debugging sort of things you can do, which is just toggle that over to exact to see if it fixes that specific Boolean operator. So now we've got a difference. So we've chopped out that big shape from our main shape, which is not what we want in this case, because we want this. So all I have to do is go click union, and you can see there it's unioned it, so added it onto the object. So beautiful. So I collapse that one down. At any point you can toggle this stack, so you can expand or collapse. So expand them all, and toggle again, and it collapses them all. So that's super handy, especially as it gets more and more. And then you can open them or close, toggle them open individually. Okay, so now this is the solid that we're going to continue from. So the next Boolean operator, we're going to do a difference. So let's cut out the whole. So I'm going to, and usually the way I do this, I usually have them visible actually. So that's the cool thing about this grouping in folders. I just click on just the parent folder, show or hide, and then all the objects are now shown or hidden. So what I can do here is eyedropper, and then click on this M3 thread, and copy, paste, fast, keep it as difference. And now if I hide them again, I've got a hole. So that's my difference, Boolean difference operator. So if that all makes sense to you and you understand that and you try it and it all works for you, that is like, I don't know, 80% of everything that I've done, I think. That'll get you 80% of the way, and all of the sort of modeling that you do. We'll get to the mirror. There's an array. What else? There's like some lattice, sort of bending and manipulating type stuff. Yeah, and then you're up to like 90-95% of the functionality to design pretty much any sort of functional component, which is pretty cool, I reckon. So that's what I really want to try and demonstrate in this video, is these bits of functionality and what you can do with it. And as I said, I'm sure there's a dozen other ways you can do this sort of stuff, better and maybe not better, but this is my method and process that I've sort of wrapped my head around and evolved as I've done it more. Cool, so I'll show this. Another cool thing in here is to give you a bit of visibility of what they're doing as you're modeling. It can be handy. Oh, just noticed a mistake here. This is a cool thing. I'll get back to the visibility of these objects. I think I've forgotten to move these, which will give me a good chance to actually demonstrate how easy it is to change the object, like, redesign it, fix it, using this sort of mostly non-destructive Boolean operator method. Yeah, so that was 16. So that should be 8. I've still got that at 12. Yep, so what I can do now is, so I've got this in the wrong position. This hole should be much closer, and the material obviously goes closer and everything. So what I can do here is usually easier in wireframe mode. I can, if I hold down, what am I doing? Holding down Control, I can deselect that. Yeah, so see here, I've like click, and I've basically within my box here, I'm selecting these two cylinders, the hole and the material. But I'm also selecting the main object. So you can see there. So now I've got like basically three. What have I got? 3, 4, because I've got the main material selected plus the core object itself. So now what I can do is hold down Control and just select an area which I don't want to select, and that deselects. I can also click on these objects and hold down Control. Like if I click click that one and Control click that one as well. That's another way to select. So these are centered at 12, but I want them at 8. Yep, so that should only be 8. So I'm going to grab G for grab, and x-axis 4mm minus. So I actually want them there. Okay, that makes more sense. And so now I want to modify this main object. So I will select the, what do I call it, main shock tower shape, tab. I want to select these, grab x4 minus. Cool, so that's all good. But I will just adjust this little bit. So now we're seeing we're getting a lot sort of closer interaction here. I'm going to grab this cutout, and I'm going to just grab, not Z, I'm going to move him kind of to here. Grab Y. So, no, actually, might move that sort of up a bit. This one is the sort of joining section. And then, yeah, so just this way is just a little bit of fiddling around, sort of position it nicely so it's kind of gonna overlap where we want. And then grab that, so we'll put that there somewhere. Cool. So now we've got those bits that I've got. Yeah, so that clearly, hopefully clearly demonstrates how easy it is to move stuff around. So if these were all one object with just a whole bunch of vertices, and you make curves and all the individual points are in the exact spot you want, and then you got to change it, it's sometimes impossible, sometimes really messy, time consuming. You don't want to be moving around individual vertices and edges and stuff. That'll just take forever and be a nightmare. You'd sort of, you just delete a whole section and recreate it. So that's like a destructive parallel. And in the way I'm doing it, which is mostly non-destructive, that shows you what you would sort of need to do to make those kind of changes and corrections, because that's, you design it once, I print it, and then I realize 15 different measurements or details need to be changed, and then you go change them, and that's where you get the real payback for this type of process, when you want to do all those changes. Okay, so now back to our object. I'll go back to the textured view. Cool, so that was pretty good. So now another thing you can do if desired is, see how we've got the textured, all these objects are textured, they're solid. So when I go to this view, I can't see through them. If you go to the wireframe view, everything's wireframe. But what I've found handy is when you're in the textured view and you've got all these Boolean operators showing and you want to kind of see what you're doing. For all the pretty much all the cutout ones, I like to do a little setting. So you select the object and you go to this object properties icon, so a little box with the sort of corner squares around it. So click on that and scroll all the way down to viewport display. So expand out viewport display, and you see this display as textured. So this is specifically for this object I've got selected. Change this from textured to wire. So I want this object to show as a wireframe. So now what we can do is we can hide materials, and I can keep all the cutouts showing, for example. So it's still visible, but it's showing as a wireframe. So even though I'm in textured view, I'm not in wireframe view, this particular object shows as a wireframe. So I can see that it's actually doing its job, which is cutting the hole out of my main object. Because if I had some issue and it was, the vertices were conflicting, this might still be solid, and then I can see there's a problem. So that helps a little bit in that way. And you can sort of see what the final object shape is as well, whilst still having the cutouts visible before you want to hide it all and you finish with the object. So I often do that with all these sort of cutout ones. Change them all to wire. You don't have to. That does not change the actual program or the object in any way. It's purely a visual cue or a visual sort of construct for us to see. So I can make all those wireframes. It sort of lets the actual main object stand out better. Makes it maybe a bit easier to work on. Okay, so now we want to, so we've got the shock tower. We go back to our spanner, our Boolean operators. I'm going to toggle this open. I'm going to collapse the few that we've already done. So now I'm just going to go through and quickly populate all of these other ones. So where did I get to? I did the mount, and that's it. So eyedropper, M3 thread, fast, eyedropper, that one, fast, eyedropper, that one, fast. So is that in the box? That cylinder. Curve 2. And that box there. Cool. Awesome. So I can see an issue there already, which I can show you a cool thing, hopefully. Okay, so now I just happen to have added the right number of booleans, which is just random. If you copy. If you need more, you just keep adding them as we did. And if you add too many, so just say I go QB, and I've got another boolean here. I don't need it. This little X will close, or just delete it, or remove it out of the list. So I go, don't need that one anymore. Cool. So collapse. What have I got here? Let's go through, just do my naming process. Again, this is sort of optional, just the way I do it. You can type in a name if you want, but I find this is the quickest and easiest because I don't want to type in manual names of something which is the same thing, so I just copy paste. So I just sort of go down the list, copy paste them all, set them all to fast as a starting point. So make sure it's all, click on either fast. Cool. And then toggle it back. So now I've sort of added everything quickly, and now I can look at it, and here is exactly what I was here's an issue. So you can see that there's no hole here. So for this one it works fine, there's a hole. So that's one of the cool things about putting this as a wireframe, because if this is a solid, you you sort of can't tell that there's no hole there, if that makes sense. So if I put this back to textured, so I've got my main object, I've got my other whole cylinder here that I meant to cut a hole, but I can actually tell that that's not cutting a hole. So that's a perfect demonstration of if I change that to wire, so I can see this one's good, this one's cutting out that curve nicely, all the others are doing their job, so all perfect, but this one is not. So what I would do is I'd go to the top view, probably go back to wireframe, and my first, well, in almost all cases, it's because there's a vertex that's clashing with another object. So what I do is I just move it, 0.01. So I just grab this 0.01 in the y-axis, let's say, and go back to the textured view, and that hasn't fixed it. So then I would grab it in the x-axis and go 0.01, and it still hasn't fixed it. So now I go, right, well, that's not the issue. Well, probably not the issue. The other thing you can do there is you grab it, move it quite a bit, see how it's still not working. So it's not cutting a hole anywhere, so it's not that issue. So let's go back to our main. Oh, okay, I think I might have added it twice. So let's expand these ones. What did I do? Shock mount outer. Shock mount outer. Thread. Yep, so see here, I have, this is a good demonstration as well of what can cause that type of issue. So I've added the exact same object twice, and that really messes things up. So you can actually see here, which isn't immediately obvious, but see how this has rendered with a bunch of kind of random orange lines. Like, it looks all sort of a bit scattered. It's not following the lines of the actual object here that's being cut out or doing the cutting. You can see they're kind of a bit fragmented and not at the same angle, like off at a weird angle. So that's also a clue that there's something clashing there. And in this case, it's because I've added this cylinder twice instead of one each. And you can see also here that when I've copied and pasted, I should have noticed this. So when I copied and pasted the name, it's Blender has said, oh, this, what you just pasted was a duplicate of this other name. So all these have to be unique as well, same as the objects. So what Blender's done is, oh, it's unique, so I'm just going to automatically suffix 001 onto it, which if I notice that would also tell me that, oh, wait a minute, why has that happened? I've used the same object twice. So that's a key thing to look out for that's easy to do, as you've just seen. So what I want to do there is simply get rid of that. So you see now that I've deleted the second instance. So see now all those weird orange lines have gone. So that means that's fixed. And then I want to grab, so this object instead. So I'll copy that, replace the name here to what it should be. Cool, so now we can see we've got the two holes perfect, and happy days. Awesome. Okay, so that is half of our object. And so now we've got all these Boolean operators. So now if we go Q and M for mirror, it has done something straight away, which is not quite right. But so I've got a mirror. We're mirroring across the x-axis, which is the default when you add a mirror operator. But what it's done is it's mirrored itself on its origin. So remember I added that little tiny cube which is sitting at these coordinates actually. So it's sitting at like randomly, 4 and 4. So whatever, I'll make that 4 and minus 4 just for fun. So that's where that little cube is sitting, which will be inside our final object. But that is the origin of the object. So what this mirror modifier has done by default is to mirror the whole object around the x-axis or across the x-axis, but based on that origin point, which is not quite what we want to do. We want to, the way I've set it up, I want to mirror it across the actual 0 point, which in this case is our 0 line for the x is 0. So not 4, we want to go back to 0. So what I do as my best practice is I do Shift A and I add another object, so mesh plane. So it could be all sorts of things, it could be anything really. But a plane is like a sort of two-dimensional object in this three-dimensional space. So if I add a little plane, it just gets represented, I'll just lift it up a bit here so you can see it, just gets represented as this two-dimensional square. So if I tab into it, see it's only got 4 vertices and the edges and one face, so it's actually a two-dimensional object, so it's not something you could ever print. But we don't want to print it. I just want that to sit at the 0, x0. The y doesn't really matter, so I'll put that at 0 as well, just for fun. Let's all put it back to 0. So it just sits there. So it sits there in space. But critically, it's on our center line. So I'm using the y-axis as our center line for this object. If I design this object off to the side somewhere, not on the view's y-axis center line, like it was over here, it doesn't matter. I'll just literally put that wherever the center line of my object, where I started it from. So if that was at 40 millimeters out over here, I would just put that plane at 40 millimeters. I would have all my objects built here, and it would mirror itself. So you can see here, I've got my plane. I'll pop that into the materials, and for best practice and uniqueness, I will call it shock tower plane. So it sits there. But what I want to do is, for my mirror modifier, I want to actually tell it to mirror my component around an object. So same thing, pick the eyedropper, and I'm going to pick that plane from my list. So now it's mirroring around its origin, and now you can see, magic, we have the full component that we're trying to make, which is super cool. And I'll hide the cutouts. And there you go. How cool is that? So if you're following along after you've watched this a few times and done this for yourself, congrats, you've created your first component in Blender, which is super exciting. I remember the first time I did an object and then sliced and printed it. It was mind-blowing. It's like you've created something from nothing, which is awesome. So yeah, there's an object, and then you can like sit and spin around it like a madman for a few hours, enjoying the beauty. Or you can print it. So next step, might be this video, might be another video. Let's see what happens in editing. If it's the next video, then keep playing. If it's this video, keep listening. I'll show you the next sort of phase of the process, which is exporting from Blender as an STL and then importing into the slicer. So that's pretty cool. Is there anything else I want to show? I reckon that's pretty good. Pretty good for now. Alrighty then. So now that we've designed our unbelievably beautiful component, in this case it's a rear shock tower for the Lucas agitator 1/10 Pro 10 car, which looks like this. So this is the original piece that I'm replicating. So the next step is to, well, we want to ultimately print it, 3D print it. But the next step in that path is to export it as an appropriate format. So s.stl. Let's look it up. I can never remember it. What does STL stand for? 3D printing. Here we go. Stands for stereolithography. Named after the technology that created the format. It's also widely interpreted as standard tessellation language or a standard triangle language, referring to how it describes 3D models as a mesh of tiny triangles, sort of. The format.stl extension encodes the surface geometry, allowing CAD designers to be converted into printable instructions for, or CAD designs even, not the designer themselves, to be converted into printable instructions for 3D printers. Sounds good. So yeah, there you go. That's exactly what we're doing, and that's the definition of STL, stereolithography. And if you're doing like more organics, sculpting and this type of Blender program, so I've shown you a very, very basic structural, engineering type structure, which is all cubes and squares and flat surfaces. But if you are sculpting and designing organic structures, you tend not to have rectangles, you tend to have triangles. So you get a whole lot of vertices, edges, and faces, which are little triangles, and there'll just be thousands literally to make a a sort of complex organic structure. So that's where the sort of mesh of triangles comes into it. Standard triangle language. Cool. See how long I remember that for. Won't be long. Okay, so back at the beginning, we did some configuration of our environment in the preferences, and one of those add-ins, the extension add-ins, was the 3D print toolbox. And once we've done that, what that gives you is this little 3D print tab here. So with all these measurements, location, dimensions, that's all in the item tab for the objects that you're selecting. But if I go and now click to 3D print, we get this 3D print menu. There's a couple of things in here. One is make manifold, which I'm not going to go into now. It can help fix up broken objects which aren't manifold. So it means all your vertices and all your faces and everything have to be all joined up and forming a solid. So, in a CAD program, you can have something that's not solid, and it doesn't matter, but you can't physically print something in the real world that's not solid. It defies the laws of physics, which is fair enough. So in here, it has that feature. I won't go into it. Sometimes it helps, sometimes it completely destroys your object, and you have to do Control-Z to undo. So anyway, I'll just collapse that, and I'll collapse that bit. So the export here is what we want. By default, it'll just be the current directory, and I'm going to change that And I'm also going to show you, I'm just going to go up a folder. So this is the way I do it. Totally my own folder structure or process of storing the files. I don't know if other people do the same or similar. I'm sure there's a million different variations out there. You do what makes sense for you. Here's my example, which you can follow or not, or do a variation of. So I create like a template folder with these 5 subfolders in it, and so I've got number 1. I number them so they sort. You can sort them sequentially, so they don't sort alphabetically. But putting a number like 1, 2, 3, 4, 5 means that when you look at them in the Windows Explorer or your operating systems Explorer, and you sort them by the name, they'll sort nicely. And so I create like a little template, save that sort of in my parent folder, and every time I start a new project, I will create that template folder, just make a full copy of the parent, and rename it to whatever this purpose is. So this one I called it like this purpose for this tutorial, Blender for 3D printing for beginners. And then also in my template folder under the number 1 folder for Blender, so this is the actual Blender file. So if I go into here, you'll see I've got the original template. And then when I start a new project, I'll either rename this or just copy a new one. So in this case, I copied it and I renamed it to something else. So this is just my standard Blender file. You don't have to do it. It's just a convenience step. So it's easy. It's just there ready. I can just go open it, rename it, save it, whatever I want to do. And then so you get a .blend file, which is what you get when you save. So I'll just cancel this. Also, you see this asterisk, so it's always good to save. Control S. Save as often as you think of it, because if Blender crashes, whatever you've done since the last save is gone. Or most likely, you might be able to recover it, because what you'll actually see here is there's .blend, which is your main file, and then .blend1. So that's kind of your cache backup. So if it does crash, you can try opening that. You can double click a blend1 file. It'll open in Blender just the same, and it might have cached more of what you've done. Most cases you'll lose what you've not saved. Same as many things. So make sure you save often. So there's no autosave. Blender used to crash periodically in the earlier versions, but it's progressively got better and better, and it's very rare for it to crash, I find, which is awesome. So super amazing, but always save frequently. So now the final step of this part of the process. So we'll wrap up this video shortly for this part 2 before we move into part 3. So now we want to export our model to an STL file. So in the 3D print tab here, that is now available because we added the 3D print toolbox back when we configured our environment. And within this tab, we have a section called export. So in our export, we want to set our target folder. So I'll just open up this target folder, and we can see here where I've saved my blend file into the Blender folder. So I'm just going to go up I'll just go up one folder here to show you the way I've structured my sort of subfolders within each project. So I've got the numbered 1 to 5, one folder for Blender, then STLs, slicer files, G-code files, and then a reference folder. So that's where often in the project you would have lots of photographs, text reference documents. So I store them all in here, so it keeps them handy. So, but in this case, what we want to do is store our STL file. So I'm going to tell Blender that this is my target folder. So 2_STL, I'm going to accept that. I'm going to tell Blender that the target folder for saving the STL files in is this one, 2_stl. So I'm going to select that and accept. So you can see now the target folder has changed to the current directory, go up to the parent, and then back down to 2_stl. So now that we've set that for this file, it'll save it. It'll stay like that ongoing. With format is STL, so you leave that as the default, and then we can export the file. So down the bottom bar gives an indication that the file's been exported. So now, if we flick over to the Explorer, we can see, if I navigate down into the STL folder, we can see that this STL file has been saved, which is where we're going to wrap it up for this part 2 of the video series. And in the next series, we're going to basically take that file and import it into our slicer and manipulate and configure it how we want to print it. So that's where we'll wrap up now. I hope you enjoyed this part of the series. Please join me in part 3, and I'll show you all about the slicing.